Bismillahirrahmanirrahim. Greetings. This is going to be a continuation of the previous lecture, and I'm providing the site link of that in the comment section below. That lecture was kind of introductory for this lecture, and also one more to come. Now, the goal is to find the rule of correspondence, to find a function from the finite set of natural number to the set of sequence of partial sums. Partial sum of what? Partial sum of 1 square, comma 2 square, comma 3 square, and comma n square. So this is the sequence, and the sequence of partial sum of it will be the output of our function, if there is such a function. So we know the input, we know the output, and we are trying to find out what is the function that the input of that is this and the output of that is that. Do you follow me? So what we do, we go and look for help from the examples that we are already familiar with, so that we can extract information and use them as a clue, as a hint, to hopefully find that function that we are after. So let me now zoom in the one that I have for you. I selected easy one so that we can get the concept more in detail. So let me zoom it if I may. Now, let me stay out of your way. Now here, our function is f of x equal to x squared. The input of this function is, I went up to 5, 0, 1, 2, 3, and so on. The output of that, as you can see, is 1, then 4, 9, 16, 25. Now, what are these outputs? These outputs are points on the vertical axis. Is that right? Now, the points on the vertical axis can give us information how that function is behaving, how it's going up or going down or staying same or what have you. Now, here, the points on the vertical axis, from 1 it goes to 4. You see that? So it goes 3 units up. Then from this point 4 to 9, it goes 5 units up. Then from 9 to 16, look at that, it goes 7 units up. You see that? The point that is going up is not kind of same, is not constant. So we get a feeling that this is the output of some kind of quadratic function. So let me cover that one. Let me cover that. We pretend that we don't know is f of x equal to x squared. What we do know is that this is input of that function, and that is output of that function, and the difference of that will help us how that function is behaving. So let's go and see how the difference of that will be, that we already discussed. The difference here is 1. From 1 to 4, the difference is what? It goes 3, so it goes 3 units up. The difference between this point and this point is 3. The difference between this point and this point is 5. You can see that. So from this point and this point, he's not going up with the same units, as we can see that. So let's now look at the difference of the difference. Difference of the difference, look at that. From 1 to 3 is 2, and then is 2 again, and 2 is there, and 2 again. And the difference of the last one will be naturally 0. Is that right? 2, 2, 2, 2, 0. So that gives us good information that the function, the data, these two data, input and output, will be output of a kind of quadratic function. We know it's not linear because the difference of the difference is the linear. Now, the other thing we do know is about the derivative of the function that I have written here for you. And if my function is f of x is x squared, the first derivative of that is equal to 2x. And what is derivative? Those of you who are familiar with calculus is what? Is the rate of change of the function. How is it changing? How is it going up? This function tells you what is the rate of the function before that. In this case is x squared. And this function tells you what is the rate that this one was changing. Look at that, this was changing 2 and 2 and 2, you see, so it was a constant. What was that constant? 2. You see, the second derivative is 2. And finally you get 0. And this what you just notice of difference is characteristic of all polynomials, of all polynomial functions, is the characteristic of all polynomial functions of degree n, where n can be any positive integer. Okay, now let me give another one just for extra input. Now for the next one, let me see. Now my function for the next one is x cubed, all right? And look what happens. This is the input of my function. Let me cover it. This is the input of my function, and that is the output of my function. Is that right? X cubed. I give 2, it give me 8. I give 3, I give 27. And look at the difference. Difference are these numbers, which is not like before, and not the difference of this one. Look at this one, the difference of difference. And the difference of the difference here is this. You see, the from 6 to 12, from 12 to 18, they all raised with the same. So this is linear. You know, if you don't know the function, somebody, I say, if this is the outcome of some kind of function, what is that function? From the outcome, we can see that function should be linear. And if this is linear, then it gives us the information that this is the output of a kind of quadratic function. And that gives us information that this could be the output of a function of degree 3, of a polynomial function of degree 3. You see, the difference can give us a lot of information about the function that you are after. Now here I have written the derivative, the first derivative, second derivative, third derivative, and fourth derivative. The fourth derivative of f of x equal to x cubed will be 0. And the derivative, if you are familiar with the differential calculus, it tells us how the function is behaving, how the function is going up or going down depending on the given function. And in the case of polynomial like this, he tells us what is the rate that is going up. You see that for the first one, and this tells you what is the rate of this is going up. And this is telling you the rate that this goes up is constant, be the same. 2, 6, 6, 6 is going up, and so on. Okay, now I have another one. Let me also give that one a little bit kind of more detail, if I may. This is kind of a little aside. My function is x cubed. So you see that the first derivative is quadratic, second derivative is linear, you can see that, 6x, and the third derivative is constant. That happens all polynomial functions of degree n. Now I have generalized that one. My polynomial is of degree n, where n is a positive integer number, a given positive integer number. All right? And then when we do look at that one, those of you who are familiar with taking derivative, and finally look what happens. We end up to this, and then derivative of this one will be this. This is all coefficient of x. And then derivative of that one will be 0. So that is property of all kind of polynomial functions. I'm kind of repeating myself. Now we go back and see what we had pretended to see if we can find that function. So that is now our goal. Can we find that function? So let me cover it. And let me also zoom it if I may. Okay, I hope it's good. Read about. Now here, we pretend this is the input of a function, this is the output of the function. So the function is getting 1 and giving us 1, gives 2, gives me 4. I give him 3, he gives me 9, and so on and so forth. So we pretend we don't know it is f of x is x squared. We only know this is the input and this is the output of that. So what will be that function? So the general form of a quadratic function is ax squared, f of x equal to ax squared plus bx plus c. All right, I have written that for you here. That's the general form of a polynomial function of degree 2. Now, with this information of knowing input and output, we want to know what is a, b, and c. All right, so let's try it. So I know that f of 0 is 0 from this data. I know f of 1 is 1. I know f of 2 is 4. So I'm going to plug this one and come up with this. So I give him 0, he gives me 0, is that right? So x is 0 equal to 0. So f of 0, which is 0, implies c will be 0. Do you follow me? So when I put for x0, this is 0, this term. When I put for x0, this term is 0. And I'm left with c, and f of 0 is 0. So c is 0. Fantastic, I found my c. So I go to the next one. I give him 1, he gives me 1. You see that the input is 1, the output is 1. So when I give 1, I get a. I put for x1, I get a. I put for x1, I get b. So a plus b will be the output, which is what? Which is 1. So a plus b equals to 1. I have found one equation. Now I go to the next one. Because I have 2 unknown, so I need another equation to find so that I can find my a and b. Now this time I give him, the input is 2. When I give to that function 2, that function is giving me 4. I don't know what that function is. Don't forget, it's general form. He give me 4. So I give him 2, he give me 4. So when I give for x2, I get 4a. Is that right? I give for x2, I get 2b, and the outcome will be 4. Is that right? Do you follow me? So I got my second equation. So right now I have 2 equations with 2 unknown, and that is very elementary basic algebra. I can find what the value of a and b are. So what is that? By elimination, I can eliminate b by multiplying this equation by -2, then adding to this, that eliminates b and tells me what is a. That's exactly what I have done. Do you follow me? I have multiplied by 2, I eliminate that one, and I end up with 2a equals to 2. That means a must be 1. You follow me? So if a is 1, then b must be 0. Is that right? With respect to this equation. A is 1, b must be 0, because 1 equals 1. Don't be mechanical and go ahead and add to both sides -1. Just look at it yourself. Just contemplate, think about it. If a is 1, in order this equation to be valid, true, b must be 0, because 1 equals. So that means what? That means b is 0. Fantastic. So we found out a was 1, b is 0, c is 0. Therefore my function will be f of x equal to x squared. Now let me zoom this one up if I may. Okay then, lo and behold, we found out that our function, with the knowing that input and output of that, the rule of correspondence between input and output to be f of x equal to x squared. And because we are working with integer part, with the natural number, So we can say f of n equals to n squared. Fantastic, is it not? So we are going to use the same kind of analogy, the same kind of hint that we got from this to find out what will be our function that we are after, that the input is sequence of natural numbers, the finite sequence of natural numbers, and the output is again what? Is sequence of partial sum. Partial sum of what? Partial sum of the sequence of 1 square, comma 2 square, comma 3 square, comma n square. So that will be the lecture for the next coming series, next coming video. Okay, then I hope these videos are beneficial to you, and as always I wish you all prosperity and good health, and please stay safe. I always finish with an army salute. So long.